So now moving on to the buffer demo, I'm going to go ahead and take Lockraven UST, Lockraven Streams, the two watershed layers, and these are the entire Maryland data set, so I don't need those, but I'm going to go ahead and just slide them into my buffer data frame. And again, for housekeeping purposes, I'll just collapse my clips, and I'm going to activate my buffer. And so now I'm back to having that same base data. And now we're going to be demonstrating how we create a buffer around these streams. So let's say, for argument's sake, that our area of interest is going to be, say, a 500-foot critical area around all streams within the Lockraven reservoir watershed. So again, that thick black line represents the boundary of the watershed. Any precipitation that falls within this black line ultimately is going to wind up within our Lockraven watershed drinking supply. So we want to look, the first part of our analysis, again, this is dissolve in the clips, were really our data preparation. Now we're actually going to do some analysis here with the buffer and then do some analysis with the overlay. So what I'm going to want to do here is indicate that I want a consistent 500-foot buffer around all of these stream segments, because I want to find out how many of these different underground storage tanks fall within that particular critical area. So again, I can use geoprocessing, or I can use the toolbox. In this case, I'm doing a proximity analysis, so buffer is going to be one of those tools. So the actual toolboxes are here, and then of course we have our actual tool, which in this case is a buffer. You can also do multi-ring buffers if you're doing, say, a 10, 20, or 30-mile radius around your particular business. That would be one point, so it would do multiple rings at one time. In this case, I'm just going to do one consistent buffer of a consistent distance from all of these different streams. So what I'm going to do is go up here to geoprocessing, and I'm going to say buffer. It's going to ask me what my input features are going to be. So basically what I'm buffering the Lockraven streams. And I'm going to write that layer out to a new file, Lockraven Streams, and I'll just call that Lockraven Streams buffer.shape. And then I'm going to specify a linear unit. If there was a field that contained a certain distance from the streams that we were interested in, we could actually click on that radio button and select the field that we were interested in buffering on. In this case, I want a consistent buffer of, say, 500 feet. So I'm going to change the units here to feet. And then we have different choices in terms of the side type and the end type. So I can have ArcGIS buffer just to one side of the stream, the left or the right, or do a full buffer on both sides. So in this case, I'm going to take the full, and then how it rounds off or flattens the buffers when a particular feature ends. For example, cul-de-sacs in a street network just end. So that gives you an option on how to end the line, or excuse me, the buffer around the end of a line, just like in a stream network. I'm going to move this interface out here for just a second. And so what I'm talking about here is as we're establishing a 500-foot buffer on either side of a line, I'll use my arrow here, it determines whether I want to have a flat line for my buffer when it creates it across the back end or the end of a stream segment, or if I want it to be rounded. So we'll see the difference here in just a second. I'm going to go ahead and say rounded because we could have some underground storage tanks that fall within 500 feet of the head of a stream. So I'm going to go ahead and say full and round, and I'm not going to dissolve this, but I can choose to dissolve any of the boundaries that may overlap between the different streams. I'm just going to go ahead and say none for now and see what our results are. And I'm sorry, I realized I was doing that on my other screen. So I'm going to bring that back, and I'm going to say here that I'm going to do an end type of round, a side type of full, and I'm not going to dissolve boundaries between all the different buffers. So when I go ahead and run that 500 feet from the streams, I'm calling it streams buffer. And again, it runs that process. And so it did not dissolve between the features. So you can see here, this buffer right here is only for this stream segment here. I'm going to go ahead and close that out, and then click here, and you can see it highlights that, and it's only for that particular stream section. Now, you may need that to where each of your individual sections of stream, again, I'm going to go ahead and just select that particular stream, or this particular stream over here, and so you can see that the buffer is for that entire feature, and they're sort of piled on top of one another there. So what I might be interested in is just having that all dissolved out, so I can actually run that buffer again. I'm going to remove that. I'm going to clear the selection here, and I'm going to run the buffer one more time. I want to run it on streams, and I'm going to call this Lochraven Streams Buffer 2. It's my second one. I don't want to overwrite it because I don't want ArcMap fighting over the file, especially if it's still holding on. Even though I've removed it from my table of contents, there could still be a lock file on it. So I'm just going to write it out to a whole new name. I'm going to say 500 feet again. And then I'm going to do full on either side of the stream. I'm going to do round, but then dissolve type, I'm going to say all. And I can choose to dissolve on a field as well, similar to the dissolve that I demonstrated earlier. But I'm just going to go ahead and say all, and I'm going to say OK. And it's going to run that dissolve, and now I have a polygon that is one consistent polygon rather than multiple polygons, because again I'm just designating what my area of interest is here. So I'm going to go ahead and zoom out to the Lochraven watershed. Do zoom to layer here, and now you can see I'm going to turn off those underground storage tanks in the streams for just a second, and basically I have one big polygon that represents my area of interest within the Lochraven watershed. Now I do have some of the streams that go outside, so I'm going to clear that, and I'm going to zoom back to my Lochraven watershed. And so a lot of these go outside of my watershed because the buffer goes beyond the edge of the stream. But I'm not going to worry about that too much. One thing that I could do if I absolutely wanted to is I could go ahead and clip my buffer with my watershed, and then I would be guaranteed that I would not accidentally pick up any of the underground storage tanks that would fall outside. But another thing that I did, remember I did my clip earlier, and I did exclude everything that fell outside of the boundary. So I am guaranteed that I'm not going to actually pick up any of the underground storage tanks outside of the watershed. And just kind of doing a pan and scan here, I'm kind of confirming that. I'm going to go ahead and right click on that, zoom to layer, and so now I'm ready to do analysis. I'm interested in finding out not only what underground storage tanks, but what types of underground storage tanks fall within the 500 foot distance of all the streams within the Lochraven watershed, and maybe I want to schedule those for inspection. So what I'm going to do here is a simple select by location, one of our types of queries that we learned earlier, and I want to select from the underground storage tanks that, and my streams buffer is going to be my source layer, and then my spatial selection method, I've got several to choose from. I'm just going to say are completely within the source layer. So what I'm saying here is I want to select from the underground storage tanks that are completely within this particular layer here, and I'm going to say apply, and now I've identified all of the underground storage tanks that fall within that 500 foot critical area. So one of the things I can do here is I can open up that attribute table, and I can see that 59 out of the 662 that fall within the watershed are within 500 feet of my streams that lead into my drinking water reservoir. So I've hidden a lot of the fields here, not giving away any information about owners and addresses. All I have is a tank capacity and then the type of substance. So if I wanted to know by substance how many different types of or how many gallons of each type of substance, heating oil, gasoline, kerosene, diesel, fuel, I could just go ahead and summarize that. I'm going to go ahead and right click on the substance field, and I'm going to do a summarize, and what that's going to do is write out a whole new table. It's not going to have any kind of geometry to it. It's just going to be a summary table, but I want to have a total capacity for each of the types of substances, so I can maybe include that as part of my environmental report. So when I go to my output folder here, I'm going to tell it that I want to write out a DBase table, a DBF file, that is going to be, I'm just going to call it substance summarized, or substance sum, and say save. And I'm only going to do it on the selected records because those are the ones that fall within my 500 foot critical area. I'm going to say OK, and I'm going to add that table in. And so basically what it has done is collapsed down all 59 of these values down to a simple table that tells me for diesel fuel, we get a count field that tells me how many diesel fuel underground storage tanks fell within my 500-foot critical area, and it also tells me what the total of those 9 diesel fuel tanks is in terms of their capacity. So we're talking about 52,000 gallons of diesel fuel. So if I wanted to prioritize this, maybe I just wanted to pick off the low-hanging fruit and say, well, there's there's 1,000 gallon capacity of some other type of underground storage tank. Not really sure what that is. Maybe I do want to look at that one first. I can pick that off easily. Maybe I'm interested in or I'm concerned with heating oil being a problem, and so I know that I have 18 storage tanks that I have to look at for a total of almost 50,000 gallons of heating oil that could be entering into these critical stream areas. So again, now we're asking questions. Now we're doing analysis. Now we're getting to the point where we are using the GIS, not just making data, making some basic maps, but we're actually starting to ask some questions that we can incorporate into a full report and that we can incorporate into a set of maps that would go ahead and start to answer some questions. And again, that's what we're all about with regard to GIS. It's a decision-making tool, and so we want to start using it to ask questions and make some decisions. So again, an environmental application here. So the next part of the demonstration for this environmental application is going to be quantifying the amount of land use within that 500-foot buffer around all the streams. Land use is one of the drivers of water quality within our streams and within our bodies of water. So it's going to be critical to know where we have land uses that could be detrimental to water quality. So I'm going to go ahead and use the overlay video to demonstrate that using my 500-foot buffer.